Hi, you are now into the third section, dealing with 2D physics. In this section, you will learn how to deal with 2D physics in Unity and how to use it to achieve believable movements. You'll be taking a look at controlling the character and learning about colliders. Now we move on to the first video of this section, 2D physics. In this video, you will learn about rigid bodies, the collider, and types of collider. Adding physics to any game adds realism and makes it more convincing to the player. You can still make games without the use of physics, but you will be giving up an opportunity to make your game a lot more awesome. Unity's 2D physics engine is very similar to the 3D one. Almost all of the physics components have been integrated into the 2D engine, with a slight difference in names: Box Collider 2D, Circle Collider 2D, Rigidbody 2D, and so on. It is important to understand that 2D physics components will not interact with 3D physics components. Even though both share a lot of the similarities, 2D physics only occur on the X and Y axis. And rotating an object using physics will only occur on the X axis. If you wish to change any of the settings of the 2D physics engine, you can find all of its properties by navigating to Edit, Project Settings, Physics 2D. Just like the 3D engine, the Rigidbody 2D component controls the physical behavior of any game object it is attached to inside the scene. It also defines its physical properties, such as mass and how gravity should affect an object. To begin with rigid bodies, let's add this component to our player object. By clicking on Add Component Physics 2D, Rigid Body 2D. The inspector should look like this. Let's see the main features of this component. Mass. Mass of the rigid body. The greater the value, the greater the force that will be required to move the object. Linear drag. This is the amount of friction that a force has to work against to make an object move. Angular drag. This is the amount of rotational friction that a force has to work against to make an object rotate. Gravity scale. This is the amount of gravity that affects a game object. The greater the value, the stronger the gravitational force. Is kinematic. When marked true, the object will not respond to any physics forces around it. This is typically used when an object needs a special type of physics behavior that can be created by a custom script. In order to test the effects of the component, let's press the Play menu. At the moment, our player keeps falling down, passing through every object on its way, as we can see in this image. To prevent this from happening, we need to start using Unity's 2D colliders. So let's learn about them. In order to define the dimension of an object in the scene, we need to add a collider component that defines its shape and that reacts if a rigid body is attached to it. There are 4 types of 2D colliders in Unity. Box Collider 2D. This type of collider works better with rectangular objects. Circle Collider 2D. As given by its name, this collider works better with circular objects. Polygon Collider 2D. Its shape is defined by a free-form edge made by lined segments that surround the sprite. Edge Collider 2D is used to define a surface without using a series of other colliders. When the first 3 colliders are added to a game object, they are automatically adjusted to best fit the sprite attached to the object. Let's take a look at Box Collider 2D. Let's try to add a box collider to the objects in our scene and see what happens. Similar to adding a rigid body, we can add a collider by clicking on Add Component, Physics 2D, Box Collider 2D. We can start to add this component to the player object. The inspector should now look as seen on the screen. Let's explore the main features of this component. Edit Collider. This is a button that allows us to manually adjust the shape of the collider. This can also be done in the scene view. Next is Material. This is a reference to the 2D physics material that will define the object's behavior when colliding with other objects. Third one is Trigger. When checked, the collider will act as a trigger to fire events from the code. Used by Effector. If marked true, this collider will be used by an attached effector to define it. We will see them later in the section. Offset. This allows us to change the center or pivot point of the collider. Size. This allows us to change the size of the collider for each axis. Now that the player object is physically defined, we should do the same for the floor tiles. We can avoid repeating this operation for each of them by multi-editing them. We just need to select all the floor objects and then add the box collider 2D as we did before in the inspector. As a result, all of the objects in our game can interact using the Unity physics engine. In fact, now our player will not fall through the floor when walking on it. In the scene view, the colliders look like green boxes surrounding the objects, as seen in the image. If we press the play button, we can see that our player doesn't fall through the floor anymore. However, he stands still in the middle of the scene without the possibility for us to control his movement. Great! In this video, you learnt about the rigid bodies and the colliders and their features.